As we get into the heart of calculus, one of the important concepts that we'll be dealing with is slope. So before we actually start dealing with slope in calculus, I just wanted to review some of the things to get us the slope of a line. We have very much dealt with slopes of lines in algebra and algebra 2. I just want to make sure that we remember it all. So at the end of this lesson, you'll be able to find the slope of a line and use the slope of a line to find additional points on the line. All right, before we actually get into finding the slope, just a question that I'd like to answer. What does it mean for a point to lie on a graph? If a point lies on a graph, if I have the graph of something, let's say I have the graph of a parabola here. If a point lies on the graph, that means it's actually on the graph. So any point along here, those would all lie on the graph. A point that's right here does not lie on the graph. If I were to test to make sure it lies on the graph, if I had an equation for that graph, the point actually would satisfy. If the x and the y values, if I plug them in, they'd actually give me a true statement. So that's what we're going to do when we are working with this example. And the example says, if the point -3 1/2 lies on the graph of the equation 2x plus ky equals -11, find the value of k. What I'm basically going to do is just put in -3 for my x, 1/2 for my y, and show that I get a true statement. So plug in -3 for my x and 1/2 for my y, and I would like to show that that will give me a -11, but basically we'll be finding the k value that will do that for us. So simplifying, I get -6 plus 1/2 k equals -11. Continuing to solve, I'll add 6 to both sides, so I'll get 1/2 k equals -5. And then to get rid of the 1/2, I could either divide both sides by 1/2, or I'm going to choose to multiply both sides by the reciprocal. And when I do that, I'll get k equals -10. So that's what k would have to be in order for that point to lie on the graph. All right, as we get dealing with slopes and lines, I just wanted to make sure that we remember the different forms that a line can be in. The first one is the most familiar probably to you. That's the slope-intercept form, y equals mx plus b. And if you'll recall, the m stands for the slope of the line, and that's always next to the x value. And then the b is always going to be our y-intercept, where the line crosses the y-axis. Right? Another form is the point slope form. If you were given a point, x1, y1, any point that lies on the line, and if you were given the slope, you could write the equation in this form right here. And then the third form is standard form. We could either put ax plus by equals c, or ax plus by plus c equals 0. Pretty much the x and the y are on the same side of the equation. It doesn't really matter which form you use, they're all acceptable. You'll see me using slope-intercept form most often because I think it's the easiest to work with. All right, so a few examples here. If I want to find the slope of the equation given a line, you'll notice this one's in slope-intercept form, so I know that m is the slope and it's always right next to the x, so my slope is simply 2/3. Pretty simple. All right, if something is in standard form, if I have ax plus by equals c, and I'd like to put that into slope, I'd like to find the slope, I'm going to put it into slope-intercept form to do that, because if it says y equals, then I can pretty easily find the slope. So I'm going to subtract ax from both sides, and when I do that, I am going to write the x term first, and then to get rid of the y, to get the y by itself, I'll divide all 3 parts by b. So notice I get -a over bx plus c over b. So again, using y equals mx plus b, that will be my slope. So my slope is going to be -a over b. So let's say we have something that doesn't have letters in it. Let's say we have 2x plus 3y equals 9. Right, what we're going to do in this one, there are a couple different ways. I'll show you the long way first, and then I'll show you the shortcut. I could just solve it for y equals, just like I did in that first problem. I'll subtract 2x from both sides. So I'll get 3y equals -2x plus 9. I'll divide all 3 parts by 3. So I'll get y equals -2/3 x plus 3. And then I know my slope is just my m, which would be -2/3. Okay, so that was the long way. Using the shortcut, I found over here in the general equation that my slope was always just going to be the opposite of a over b. So you notice in this problem, the 2 was the a and the 3 was the b. So my slope is just the opposite of a over b. So notice very quickly I was able to find that slope, but either way we'll do it. All right, let's say I'd like to find the slope of a line and I'm given a graph. A couple different ways that we could do this. Since I'm given a picture, sometimes it's nice just to look at the rise over the run. And so I'll just start at one point on the line. Let's say I'm going to start right here. I notice to get to another point, sorry about that. I notice to get to another point, I'm going to have to go down 2, and then I'm going to have to go over 1. So my slope in this case is going to be the rise, which would be -2, and my run, which would be 1. So my slope is -2. Okay, if you're more of an analytical person, which sometimes I kind of am, I could pick 2 points on that line. I could pick the point 0, 3, which is on the line, and I notice 1, 1 is also on the line. And then I could actually just use the slope formula, which is y2 minus y1 over x2 minus x1. So if I found the slope that way, y2 is 1, minus y1 is 3, over x2 is 1, minus x1 is 0. So I'll get -2 over 1, which again also is -2. So lots of different ways that you can work a problem, and never feel like there's always one right way to do the problem. We got the same answer either way. All right, we're next going to do an example where we want to use a point to find some extra points that are on the line. So this example says to use the point -2, -2, and the slope of 2 to find 3 additional points that the line passes through. I'm going to do it a couple different ways. I'm going to do it graphically first. So I'll use the point -2, -2. And then there's a slope of 2. So a slope of 2 means I'm going to rise 2 and run 1. So if I go up 2 and over 1, notice I'm now at the point -1, 0. Get a few more tick marks on my paper here. Okay, and then from there I could rise 2 and go over 1 again, which would bring me to 0, 2. And it said I needed 3 additional points, so I'll do that one more time. If I went up 2 and then over 1, that brings me to the point 1, 4. So that would be one method that I could use. Another method that I could use, I could actually, if I'm more thinking analytically, I could find the equation of the line. I could put y equals mx plus b. I could plug in -2 and -2 for my x and my y. And since I know my slope is 2, I'll put that in for my m. And then I could solve for b. So I'd get -2 equals -4 plus b. Add 4 to both sides, and I'll get b equals 2. So the equation of my line would be y equals 2x plus 2. Now that I have that, I can find whatever points that I want. I could make myself a table, and I can pick whatever x values I want. So let's say I just press 0, 1, and 2. So if I plug 0 into this equation, I would get 2. If I plug 1 into this equation, I'll get 4. And if I plug 2 into this equation, I'll get 6. So those are also 3 additional points. So it doesn't matter which way you do it, they all work. So hopefully now you know how to find the slope of a line.